Welcome to Elemental Fun, a historical and cultural look of the elements of the periodic table. Welcome to Elemental Fun. My name is Grace.
My name is Cindy.
And welcome. We're going to talk about some noble gases.
So noble.
But we left out helium because we feel like it should have its own episode.
It's very special. So much.
There's a lot of stuff about helium.
Helium is a lot of things.
So we're touching up on all the other ones that no one really knows about or cares about.
Yeah.
So Cindy, tell us why it's called noble gases.
Oh, well, it's an interesting story. So they're noble because they're also known as inert gases. Do you know what inert means?
Please explain.
Means they basically just don't react.
Yeah.
Yeah, they're just not no good. They're not good at telling jokes either.
Wait, but what about like inertia?
Well, that's different.
Oh, okay. I thought it was like a root word or...
Yeah, possibly, but
I was trying to sound
a
smart.
thing. You know. Look how that turned out.
Every time I try to sound smart, it just fires back.
No, so they're inert, so they basically don't react well with other. They don't react.
Yeah.
But the reason why that is because of their electrons in the outer shell.
Uh-huh.
So every.
Do they have like set?
Yeah. So the element. Yeah.
Of electrons in their outer shell.
Exactly.
So they don't feel the need.
They have 8, and it's full.
Yeah.
So they're happy.
Yeah.
They're nice and full. Got their tummies all full of electrons.
Kind of like my tummy's full.
Mm-hmm.
That cinnamon roll was excellent.
You're welcome. So yeah, they have 8 electrons in their outer shell, which means they're very stable. So the whole point of why elements react with one another is because they want to have a full outer electron shell.
Right.
And for all of these ones, it's 8 around the outside. Mm-hmm. But since they already have 8, they're good. So they called them noble because they were basically too good to react with anything else.
So it's not because the queen farts xenon gas.
No.
Oh.
That would be impressive, though. Maybe she does. I don't know. The queen farts.
Bright red.
Thanks. Just saying. That
I'm
would
sorry
be special.
if someone from Britain's listening. I'm not trying to offend the queen.
She's a wonderful person.
I didn't say the Queen of England.
No, you just said a queen.
Yeah. So
any queen.
I just specified though by calling out all of them.
No, you just did. Yeah. Good job. Step right over that.
I'm just gonna keep digging my hole here and just bury myself in it.
So but the reason why the other elements react the way they do with each other is because they're all trying to reach that noble thing. So my joke is always, because everybody wants to be a princess or a queen or a king, even the elements. They're all trying to be noble.
And I love how you thought it was a joke that you told your chemistry students, but then you realized that's actually why they're called the noble gases.
I thought I was being funny.
Well,
apparently I was just being true.
I tried to be funny with my joke, and you just looked at me like I was insane.
Well, you're talking about the queen farting.
That's true. It's kind of good. It's kind of the grade I teach humor. Fart jokes.
Second grade, yeah.
Boy
right.
fart jokes.
Of course, that doesn't really change much for boys.
No, it's actually you could just say boy fart jokes.
Yeah,
and that
would be totally
any
fine.
Grade, age.
It's true.
Decade.
From 0 to 100.
Yes.
Yeah, so all the noble gases, since they're in the same group, they all have similar properties, so we did them all together. And because they don't really react with a lot of other things, they've got some interesting or not so interesting properties of them.
I know we can kind of, tangent just a little, but there's not a lot on these guys, but we decided to do it a little differently. So I took 3 of the gases, and you took 3 of the gases, and we kind of decided to talk just individually about their whole history and cultural significance.
And I'll interject, and you'll interject.
Yeah.
That'll be good.
Mostly I'll just go,
Oh, wow.
What?
What was you saying? So we're going to go down the periodic group in the periodic table, starting with neon.
Neon.
I was
like,
I was joking, y'all.
I got
See what it did there?
Neon.
Neon. The neon signs.
Yes.
Bang, 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 bang.
But I'll get to that.
Oh.
First off, the name neon comes from the Greek neos, meaning new. It was discovered by Sir William Ramsay.
Oh, you'll hear more about that guy.
Morris Travers in
that guy too.
1898. They were busy.
They really liked the noble gases. They were like, I found this one. I'm gonna find another one.
Yeah, they were pretty with it.
Yeah.
They discovered a lot in a short amount of time. Actually, 3 of our elements were discovered in the same year.
Yeah, 1898.
Neon was not the first of the noble gases discovered by them in this group, but basically once it was isolated, they knew they isolated because there would be a blaze of crimson light from the tube.
Yes, and so each time they found another one, it was the different color, so they knew it was a different spectrum, so they knew it was a different element.
Right.
Which is kind of cool.
But we all, in our, culture, in our language, we say neon signs, but it's really only the red or the orangish red that is used with neon, the gas neon. Other ones are used with other noble gases, or they paint the tubes a different color so that they come off that color. But really, it's just... neon's only red and orangish red.
Yeah. If you put other noble gases in it, it changes the color.
Yes. And like you said, that's how they discovered it. Different ones.
Yep, the different.
Which, 1898. Smart, guys. Smart. Like, I can't separate my socks.
And they're just like...
Here they are, taking the air and, pulling, isolating elements out of it. I'm like...
It's pretty impressive.
It is. I mean, kudos, sir.
Kudos.
I'm sure that's how you got your knighthood. I would assume.
Probably.
Yeah. I actually didn't do research on him.
I didn't. Oh, Sir. Oh, Sir. Yeah, Sir William Ramsay. Yeah, probably something about his science-y. Which is good back in that day, because sometimes they weren't all about the science.
Yeah, well,
that time they were.
Yeah, by
that
point,
time.
Yeah, I was gonna say you gotta
but
go back.
Still, even today, we're sometimes not about the science.
True.
Which is kind of sad.
We're not gonna get into politics right now.
Go back to neon.
Oh look, this whole section of
pop culture.
I just
Nothing.
Have blank.
I mean, it's in the neon sign. I mean, that's the thing.
Basically, neon signs. It's also.
So Las Vegas is really high on the neon.
Yeah, they really like noble.
Double down.
But
ride.
It's primarily. But we use the word neon kind of loosely. And basically, we use it for any bright color, even though neon is really only red or reddish orange, like I've said. But we say oh, that's neon green and neon blue, but it's really not.
It's actually not neon.
It's not neon, but I think we just have kind of adapted that word to just mean brightly colored. Which
I'll talk a little bit later about one where we do that, where you take the meaning of one word and actually it's like Kleenex, right? It's all tissue, but it's not just Kleenex. Side note, I had a neon, in that term, neon outfit. It was like big giant patches of color, like pink and orange and yellow, and I wore it to school, and then I actually used it in a play when I was the Phantom Sister in the Phantom of the Opry. But everybody would joke that they'd have to wear sunglasses to look at me.
I bet.
Because it was so bright.
Oh.
I wish I still had it. It's
impressive. It must have been your future.
Yes,
so
right.
Bright. Everyone else had to wear shades. So it's used in fluorescent tubes. It's also used in deep sea diving. And it's also used in helium neon lasers, which is the most inexpensive of all lasers. It's what's used at the supermarket scanners. So that red little scanner
really is neon.
It's neon with helium. So, although it does not form compounds or react, it can somehow be combined with helium to make those very inexpensive lasers. I'm not sure how.
I don't know.
Well,
there's one of the other ones is able to react with something else too.
I have a couple that also react. It's not typical. They don't really care to.
Well, they don't want to.
No,
it's kind of forced.
It's
a forced marriage.
I was gonna say it's like when they're like, I'll marry the princess of Spain.
I guess.
I don't want to lessen the blood of our people, but we will. Right?
Yeah.
Something like that.
Yeah.
It's like treaties. They're making treaties.
Oh, treaties.
Deep. Not really.
When you talked about the deep sea diving, was that as an insulator to keep people warm? Do you know?
My research did not say.
Oh, because the next one we talk about is a good insulator, and they pumped it into deep sea diving wetsuits to keep you warm.
It's probably similar, since they're all.
Yeah, because it was argon, and it's right next to neon, so.
That's true.
There you go.
The only other thing I really got, because I really don't have a lot, even though neon's one of the more popular ones.
But it's for one thing. It's a one-hit wonder.
It's a
one-hit wonder.
It's like an 80s one-hit wonder.
It's 1800s one-hit wonder.
But you know what? What was also popular in the 80s? Neon. And 90s.
What? Neon.
Oh,
just neon.
Just like any clothes.
Oh, everything was, like the jelly bracelets?
Oh,
yeah.
I was thinking of like the tracksuits, but that was more 90s.
Oh, yeah.
But this was discovered in the 90s.
1890s. What?
And there were a lot of one-hit wonders in the 90s. It's like that song, Steal My Sunshine.
Oh, yeah.
That was a one-hit wonder.
Mm-hmm.
I'm sure they wore neon. Neon's a one-hit wonder.
What?
Full circle.
Ba-bum.
Anyways, last thing I have to say is because it's, neon's just basically known as whatever is bright. There's even a fish, a freshwater fish, and they call it the neon tetra because of its bright blue and red stripes.
And you know that some of them, they actually, not those ones in particular, but there are some fish that they inject with dye to make them neon. It's pretty terrible.
Just sad.
Yeah. And now if you go to the stores, you'll see that they'll specifically say that these are naturally colored ones and not injected because people got up in an uproar. Like, you're injecting fish with dye. That's ridiculous.
It is ridiculous.
Yeah. But there's some that you can get with, like, UV light, and they actually glow in the dark.
Yeah, I heard
it's
they
pretty
were working
crazy.
on that.
No, you can't. Like, you have ones that, like, glow in the dark.
I was going to say, like... When I say I heard,
Let's go.
I meant, like, a long time.
Long time ago.
I heard about that.
Yeah, neon tetras are very pretty, though. Yeah. Cool.
That's all for neon. And now we're moving on to
argon.
I actually grew up near a road called Argonne, but it was spelled differently.
So it's kind of like totally the same, but totally different.
Yeah. You get me?
What was it spelled?
Argonne.
Argonne.
Argonne. Spokane does not pronounce anything like that.
Maybe there's some weird people that do.
I grew up in Spokane.
Spokane,
also
Washington.
Called Kansas.
Okay.
No offense, Kansas. I'm sure you're lovely.
I'm sure you're a lovely state.
I'm just offending everyone today.
You're doing really good. Let's do a trifecta and see what else you come up with later.
What else can I offend? The night is young.
Let's find out. So argon, yes, it was in 1894. So it was
5 years. No, I can do math.
Yeah, four or 5 years before everybody else's. Yeah. And it was, but again, Lord Rayleigh and Sir William Ramsay. Again, we'll find out more about them later. But how basically all the noble gases ended up being discovered was that they were trying to explain why the density of nitrogen from the air that they pulled out of the air, because the air is like 70-something% nitrogen, was different than the density of nitrogen that comes from decomposing ammonia. So it's heavier.
Yeah. So
there's something else there.
Yeah.
So they're like, what is it? So like we said before, these guys got really intense on figuring out what that was. And
get a life.
And there was actually in 1785, this guy called Henry Cavendish, he isolated it and he noted that about 1% of the air didn't react. So even in 1785, they knew.
That was a long time.
Yeah, it was like 100 years. That he knew that there was something there but couldn't figure it out. And then they figured out, they pulled it from the air. So they, Argos comes from the Greek word Argos, which means idle or lazy, because they doesn't react.
Makes sense.
Like nobility. It's apparently lazy. Let's go full circle there and make everybody mad.
I'm silently laughing.
So it's color. Most of these actually are colorless, odorless. Yes. They won the Nobel Prize in 1904 for probably most of their work on all this stuff.
Yeah.
In space, it's when two hydrogen nuclei, or also called alpha particles, fuse together with a silicon isotope, and that's in stars. So argon is made to some degree in the stars.
Isn't everything made in the
Well,
stars?
pretty much, but that was just a cool side note.
Oh, okay.
So there's actually a fair amount of uses, but almost all of them have to do with light. So,
a lot of them have to do with light.
Yeah. So it's used when an inert atmosphere is needed. So they produce titanium with it, and other reactive elements. They have an atmosphere of argon, so nothing else reacts. Welders use it to protect the weld area so that there's no oxidation, so the oxygen doesn't get on their stuff and break it down. In incandescent light bulbs, because it stops the oxygen from corroding the filament. In fluorescent tubes and low energy light bulbs, it's argon and mercury. And the electric discharge goes across the gas, and it creates UV light and then makes the inside surface of the bulb glow.
I feel like a lot of these are basically used in fluorescent and UV lights.
Pretty much all of them.
Well, yeah. Because when we get to xenon, there's quite the array of lights. So
yeah,
I mean, basically,
Krypton
even
too.
though this is, I guess when you think of a light bulb, like when I think of a light bulb, of course I don't understand how anything works, but
nothing.
Welcome to our podcast. You don't think it's this, isolated gas that's making this light bulb work. You're like, no, it's like glass and
there's just a wire and it turns on.
Yeah,
Bloop.
copper and there's a charge. I don't know, but it's just kind of.
Well, especially all our new fancier lights, right? Yeah. Versus our, the originals.
Candles.
Yes.
I know how those work. Actually,
good.
I don't know how that.
Let's see. Oh, they use it in double glazed windows, so they use argon to fill the spaces between the panes. Oh. It's kind of, because it's a good insulator, which is also why they pump it into deep sea diving suits to keep you warm. So same thing. Apparently, in luxury tires, to protect the rubber and reduce road noise. This one was cool. There's they use it in historical preservation. So the map of the world from 1507 and the Magna Carta are kept in the case, it's pumped full of argon. So there's again no oxidation. There's no breaking it down the ink and the thing, which I thought was super cool.
Just ruins everything.
It does. Oxidation is a bitch.
It may keep us alive, but it also kills everything. It kills us at the same time.
It's slowly killing you.
Killing me softly.
Killing us all his song. In my whole world. Okay. So yeah, and then if you add neon to argon, you get blue neon lights. Mm-hmm. This was super cool. So you got LASIK.
I did get LASIK.
And her eyes are beautiful.
Well, thank you.
She can see so much better now.
Gosh.
Hello. But did you know that the LASIK, that laser, in 1981, some guy from IBM called Srinivasan, he tested the laser on a turkey bone after Thanksgiving, like one of these lasers with argon in it, and realized this could be a really good surgical tool. And now you have LASIK to fix your eyes.
Your turkey bone.
Pretty awesome.
You gotta think sometimes with scientists, they're just like, gosh, I just ate a whole turkey.
Let's shoot it with a laser.
What? Yeah, what are we gonna do with this carcass? Should we boil it down for broth? Or let's get out our lasers.
Pew, 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 pew.
Well, this would be good for a surgical tool.
A lot. You'd be surprised at how much science stuff comes from accidents and boredom and the creative part of a scientist's brain. Let's look at it this way. Oh, it's fun. Let's see. It is one. Let's see. They don't really have a biological role. It's the third most abundant atmospheric gas. And it's increasing over time because potassium-40, another isotope. Remember, an isotope is a version of an element that has extra neutrons or fewer neutrons, a different amount of neutrons than the regular one. So that potassium decays into argon gas. So we're constantly, more is being produced because of that decay. And they obtained it commercially by, you distill liquid air.
Okay.
you basically, like you said, pull it out of air.
Liquid air.
Yeah, well, because remember, everything, liquid.
So they take the...
They cool it down enough so it becomes liquid, and then they distill it. So then some evaporates, and then you let some out, and then it's a whole little thing.
It's just kind of an oxymoron to say liquid air.
It's science.
It is. Science is an oxymoron.
And this is cool. Something new is that there's some new research that is showing that it can decrease damage to the brain after traumatic injury. And they know that xenon does this, but it's really expensive.
Yeah. Xenon's used in cancer treatment.
Yeah. So, but now they're finding out that argon might be a better, easier, cheaper use of it. Again, makes similar group characteristics.
To take them out. It's probably easier to separate.
Yeah, the argon. Yeah. Because it's pretty easier.
You would hope that's why it's. And not just because they're like, no, I like the name Xenon. It's gonna be worth more.
A bajillion dollars.
Why I have this voice?
Because it's fun. I think that's all I have for their argon. It's pretty interesting.
Yeah.
I thought the historical preservation thing was cool. I was like,
that's cool.
Nifty.
You don't think about that. You don't think like, oh, this glass case is filled with another gas.
Some kind of crazy gas.
It's not just air. Like what I'm breathing.
Like right now. Okay, so moving then down to the next one is Krypton. Yeah, well, this is my favorite because I'm kind of a superhero geek nerd. It's true.
Push up your glasses, Cindy. They're sliding down your nose.
I got my pocket protector.
Has glasses.
And they do slide down my nose.
Well, they were actually
yeah. I'm so perchy. So, Krypton was found by, guess who? Sir William Ramsay.
What?
And that guy Morris Travers, who found neon in 1898. And they were convinced that argon, when they found argon, was a new group on the periodic table. So they're like, I bet you there's more heavier ones. And so then they looked for more through liquefaction and evaporation, and then found Krypton. And then blah, 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 blah. The others, neon and all the ones. Exactly. So they, crypto comes from the Greek word kryptos, meaning hidden, because it was hidden in argon. Again, no color, no smell, inert, except that it can react with fluorine gas. And I'll get to that in a minute.
I have another one that also
reacts with fluorine.
Yeah.
For whatever reason.
You know, it's a sweet chemical.
Sweet gas. It's pretty nice.
Keeps your teeth nice.
And the krypton, if you put an electrical current over it, it gives a smoky white light. Ooh. So it's kind of sexy.
Of all the noble gases, I must say krypton is the sexiest.
Totally.
For other reasons, like pop culture references.
Pop culture, which we will get to.
Yeah.
So what they use it for is, again, light. So filling gas for energy-saving light bulbs. Mm-hmm. So that's in there. Some flash lamps for high-speed photography.
They also do that with xenon.
Ooh, yeah. Very cool. The krypton fluoride, the when it combines with fluorine, is used in some lasers. But most of the compounds that they get from krypton and fluorine, they just do it in the lab. They're like, oh, that's cool. And it doesn't actually do anything. But it's just fun. Again, they actually call them lab curiosities. Oh, no actual use for it. This was cool, though. Radioactive krypton.
Yes.
So when it's radioactive means it's basically unstable and breaks down over time. So radioactive krypton was used in the Cold War to estimate the Russian nuclear production, because if you look at all of that gas in the world, take that all and then subtract how much we're putting out from our reactors, from Western world reactors, what's left is what's coming out of the Russian reactors. So they estimated by just measuring it all and then removing, what we know that we put out, then whatever's left is what's coming from Russia. Oh. So they estimated that during the Cold War, which was really interesting.
Is it bad that when you said the Cold War, I immediately thought you were telling me something the Russians did? And then I was confused when you were explaining that. And then I was like, oh, wait, no, that's what we were doing.
Well, the Cold War is the Russians. Yeah.
I know, but my brain thought...
Oh, you were thinking Russians. They were doing it. No.
And so then I got...
That's what we were doing.
We actually did stuff during the Cold War. We were just sitting there in a fridge. And
I don't know.
Will there be war?
And maybe.
That could still happen.
It's just so true. Well, it was, again, full circle. Okay. This is awesome. Like the 1800s.
Like circle.
Circle podcast. Of life. So they also can use radioactive krypton like they do for carbon dating.
Oh, yeah.
Yeah, and they especially for ice cores, like for longer periods of time, they can use it. Yeah, which that was interesting. The lasers that I talked about, they found ones. Yeah, that they can produce energy that is 500 times stronger than the entire U.S. electrical grid. Really powerful.
Like a super laser.
Yep, pretty much.
Don't put that on my eyes, please.
No, thank you. From 1960 to 1983, the isotope krypton-86, which is how heavy it is basically, was used to define the measurement of length. And 1 meter is 1,650,763.73 wavelengths of a line in the atomic spectrum of the isotope.
Why does that matter?
I don't know. But for 23 years, that was the basic for the measurement of length. I'm like, okay.
Like, do you measure things then in, like, wavelengths of krypton? Like,
well, they just use that to determine what 1 meter is. Because all our measurements have to come from something that is weighed or measured or whatever. So that was the measurement they used. That was how long it was. I don't know what they changed it to. Something easier than the wavelengths of krypton.
Just said. A wavelength.
Yeah. So again, no known biological role. And it's one of the most rarest of gases in the atmosphere. Mm-hmm. And again, they extract it by distillation of the cooled liquid air. But of course, the elephant in the room here is kryptonite. Because
such a bad song.
The planet. So I was looking up song. There is a song. Oh, you're right. There is a song.
I was gonna say.
I'm like, no,
like,
Superman.
Were you in a closet?
Perhaps.
Me crazy. Used to call me Superman.
Oh, yep. It was a good song, actually.
It was okay.
Yeah. Well, so of course we all know that Superman comes from the planet Krypton, and of course the radioactive rock from Krypton that is his only weakness is kryptonite. So I was looking for, like, why is it called Krypton? Did they name it after the element? Which I kind of figured that they did, but no.
Of course not.
Apparently. So I found this article that shows that they did some backstory about why it was called Krypton in some early comic. And there was some astronaut guy who landed there and realized he wasn't the only one there. And there was a biologist on the planet. And it was a girl and a guy. And, there's a whole little story thing go to it. But he was going to take her back to his home planet. Then he got to a spaceship and realized the thing was broken. And so he literally goes, looks like we'll be here for quite a while. So we might as well get to know each other. And he's like, Crip. My name is Crip. And she goes, Ton.
Oh my god.
I know. So it says, our race and so students, in honor of our first 2 inhabitants, we named the planet after them, Krypton. Yeah.
It couldn't be like,
Nope.
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 Like it means hidden, and maybe like it was hidden, or they hid Superman.
Nope. Which
or like anything that makes more sense than that.
Right, but it gets better because the man and the Crip, the man, and Ton, the woman, never did get off the planet, but they founded a new race that still thrives today. So from 2 people, an entire race.
Noble guess.
Oh! Don't get the bloodlines. Don't mix them up.
You can't. There's nothing.
There's nothing else. It's all the same family.
The Rock. Like, what are you gonna have? What are you gonna breed with?
I hope you had a couple thousand kids. And even then, it's still not gonna work. Low genetic diversity. Ooh. Bad thing. That's why the noble families had such issues, because they married within the family lines, and you're about to get more mutations and more recessive genetic things, and it caused problems. Oh my gosh. So all in all, that was slightly sad. And actually at the end of the story it goes, that was an actual comic book story. So there you go. I don't know if you're better off knowing this or not. Actually, probably not. Yeah. But so we'd say the word kryptonite, like you were talking about with Neon, where kryptonite has its own meaning now, where it's not just kryptonite is the thing from Superman. It's whatever is your weakness.
Yeah.
Right. So it's kind of interesting.
But like nothing to do with the element.
Nope. Nothing at all. I mean, kryptonite's radioactive, and there's some radioactive krypton.
Can pretty much anything be radioactive, though? I was gonna say.
Just saying. If you wanted a connection, I'm telling you one.
Like, I'm pulling for
straws here. I'm just saying.
Trying to work for you here.
I was surprised. I was like, oh, it has nothing to do with the element. Okay.
Okay. Yeah. Is it my turn?
Yeah, that's your turn now.
Xenon, not to be confused with Xena, Warrior Princess.
Ooh, great show. Don't watch it again, though. It doesn't hold up.
Doesn't stand the test of time.
No. I loved it when I was younger.
Oh, I did too. Oh, it was good times. I probably did not understand any of it because when I watched it, I was like 7 or 8.
That's right. I keep forgetting you're 10 years younger than me.
So, like, all the sexual innuendo.
I'm like, that? Which is probably okay.
I just liked her. Anyways. Xenon.
Yep.
Number 54 on the periodic table. Guess who discovered it?
Ramsey.
Sir William Ramsay and Morris Travers. Yes. In the same year they discovered neon. It was a busy year. Or a really boring year, depending on how you look at it.
This is true.
They're like, we have nothing else to do except go. I don't know. Pull other elements out of the air. Literally, we're pulling it out of the air. It's an unusual noble gas because it actually will make chemical compounds. And they think it actually might be found in the Earth's core. Ooh. Because it may absorb with other minerals such as perovskite. Mm-hmm. So we might have a more abundant amount than we realize.
Well, because it's so easy to go into the Earth's crust, on the core.
Well, I didn't say it was in the core. I said it was in the crust.
Either way.
Bit of a difference between those two.
Journey to the center of the Earth.
I read that book.
I did.
No, I read his other stuff.
Oh. They made a movie too.
Yeah. Oh, no. That's not The Rock.
I like that actor. No, it wasn't The Rock.
Well, they did do it.
Oh, did they do
it? He
that?
ended up in like a dinosaur land.
Oh,
it was
that's
bad.
Right.
I didn't see it. I just saw the preview and I was like, this is bad. Like, no, I did read it. I did. It was just I've read a lot of books.
Yeah, she has.
And like, I'd have to look in my journal of things where I write down all the books I've read. Sometimes I read a play and then I'm like, have I read this play? And I look at my journal. I'm like, yeah, 4 years ago I read this play.
I don't remember anything. Let's read it again.
I was like, I only remembered this one part. Okay. Mm-hmm. Anyways, blah, blah, bleep, bloop, blah. The name comes from the Greek word xenos.
Xenos?
Meaning stranger.
Stranger. Xenophobia. That's what it.
Yep. Xeno means stranger.
Mm-hmm.
I want to know why they went with like, neon from neos meaning new, and argon, meaning, or krypton meaning hidden.
Argo meaning was. What was it? Oh, we just did it.
Oh, lazy or idle.
Oh, lazy, right? Because it was
so like gases. All they kind of go with it, and then maybe this one just like jumped out of them. They're like, stranger.
Stranger. Maybe they weren't expecting to find it.
Yeah, they might have discovered it when they weren't expecting to discover it.
Although
as you can see, I really did some top-notch research this time around for this one. Backstories are super important, but no one cares. So, xenon, it is in the atmosphere. It's not toxic by itself, but its compounds are because of its strong oxidizing agents.
Again, oxidation.
Yeah. Which is kind
that's interesting. It's the opposite than the other ones because
only when it's in a compound or something else.
Right.
By itself, he's
totally fine.
Oh, what's up, guys?
So when you get that toxic relationship,
yeah, they just bring you down
cool.
and then just destroy everything.
Everything around you.
Everything
for miles.
Find a good loved one to stay with. Be in healthy relationships.
Healthy relationships.
It's like krypton. It's used in the high-speed professional photographer flashbulbs. Mm-hmm. Xenon is actually very, very big in sun tanning bed lamps. Mm. So, like, if you look up any picture of Xenon, it's just a tanning bed.
All right. Which you shouldn't do either, because tanning not so great for you.
It's used in food processing in bactericidal lamps. It's also mixed with difluoride to etch in microprocessors. So
the little tiny
etching.
Mm-hmm.
It's used actually to keep satellites in orbit.
Oh.
Keeps it going.
Interesting.
And it's also can be used in nuclear energy and in cancer treatments. And although it's not a very common use, because like you said, it's really expensive. And,
hard to get to.
It's hard to get the xenon out of the air. And yet again, I'm just going to wrap this one up with a pretty bow. That's pretty much xenon for you. Not Xena. I could talk more about her, but that's not this,
xenon.
Not this podcast.
Yeah.
So that's xenon.
All right.
And I'm going to let you move on to
radon.
Radon.
This was the 5th radioactive element to be discovered. Wow. It's also, again, colorless, odorless. And I have to, we've said this many times throughout this podcast now, it's the colorless, odorless, and most potent poison known to man from The Princess Bride.
Oh.
Iocane powder. But it's not that. But that's the line. Is it's colorless, odorless, tasteless, and one of the most potent. Blah blah blah. Princess Bride, great movie. Sidetrack. All right.
You just sidestepped there. Sidestep
back. Okay. It's inert, but it is radioactive. And it's yellow below freezing. It's yellow. Huh. And so I think we failed to mention too, all of these are, with the noble gases, so they're all gas at room temperature, but you can change it to a solid or a liquid state depending on how cold or hot you get it.
Right.
In 1900, Frederick Ernst Dorn found it. He founded it. He founded radon.
Say his last name again.
Dorn.
Wait, it's
Frederick Ernst Dorn.
Oh, Ernst. I thought his last name was Ernst Dorn.
Ernst Dorn. That's even better.
That's the best last name ever.
No.
I'm changing mine.
Ernst Dorn.
Grace Ernst Dorn.
Ernst Dorn. So this is one of the only ones that's not founded by the Ramsey guy.
He was pissed.
She's like, man.
1900. He's like,
son of a.
So close.
Almost had them all.
Frederick.
Frederick.
It's probably his intern or something.
Stupid Ernst Dorn.
He took down all his notes. He's like, I'm going back to my country.
No, it's not fair. Its name comes from radium because it was first detected from emissions of radium. They found the radon in it during its radioactive decay. And what's interesting is a few scientists from 1899 to 1900, including the Curies, Marie and Perry.
I can't wait to talk about them.
They're super cool. They detected a gas from radioactive decay, but 1900, Dorn was one that discovered it, and he detected it and observed it and showed that it could be condensed into a liquid in 1908. And then, talk about Ramsey again. Sir William Ramsey comes right around.
He totally wiggled his way into this one. He's like,
totally did. Sir William Ramsey and Robert Whitla Gray collected enough to detect the properties of it and noted it was the heaviest gas known. Wow. So the Dorn found it, and then these guys were actually able to find out all the properties of it.
Right. Because he just couldn't let it go, could he?
No. He's like, I'm going to get some of this radioactive stuff. So radon will decay into radioactive polonium and alpha particles, which are those hydrogen nuclei. And it's useful in cancer therapy. But this is the really weird part. So they would take the radon, and put it into tubes, and then insert it into the tumor. And then let it just radioactive in your body in the tumor.
Pew, 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 die.
Yeah,
Die,
but like inside your tumor. Like they put a little tube and they put it inside your tumor. Yeah. So obviously now not so much a great way to do things. So they've opted for some newer cancer therapies. Oh. But that was original, was take a little tube of radon and stick it inside you and
working.
Let it.
The person's just dying.
There's this more. But what's interesting too is that there's it is radioactive, so it'll help with cancer treatments and back in the day, and there's no biological role, but they think it has a significant role in our evolution because much of the radon comes from Earth's background radiation. There's a lot of that background radiation comes from radon, and radiation, amongst other things, cause mutations. And mutations, now I'd like to do a side note here. Mutations always get a bad rap.
Yes.
That they're terrible, or you're going to become the Hulk.
Or you're an X-Men, which I really want to be.
Right.
But I wasn't born that way.
No. And that's not how mutations work. But, so how we have evolved... X-Men.
It's a little late for me. I'm usually asleep by 9.
Yeah,
and
it's almost 11.
It's almost 11.
Yeah.
So, there you have it. I'm not going to apologize.
Yeah.
This is when we can podcast.
It's just when it happens.
So.
Just makes it more fun.
Yeah.
But yeah, so that's caused the genetic mutations that have helped us evolve over time. Probably came from that.
I mean, it's a good theory.
Yeah, it's pretty cool.
I mean, it makes sense.
Yeah, I mean, it totally makes sense. In 1879, there was a malametalorium, which was a wasting disease from miners, and they found it was from lung cancer by the exposure to radioactive radon and uranium.
So, who were these people that were exposed to radioactive radon and...
Like miners. They're going into go mine.
Okay.
Yeah.
My mind went to like miners, like
little kids.
Little kids, and I was like,
well, there probably were a ton of little kids working in the mines.
No,
that's
actually
that's totally true.
That is true. Is that where? No, it's spelled differently. I thought for a second, I was like, wait, is that where the word miners comes from? They just send little kids down the street.
No, 5-year-old.
Not spelled. Well,
no.
I mean, look at the
Yeah, I know. 1879. There was. You didn't live that long either, so there's that.
They also were like, the hole's not big enough for grown-ups. Go on down there, Timmy.
Yeah, exactly. You fit right in there.
Bring back some coal.
So what's interesting is that so it's everywhere. We breathe it in.
Yeah.
We breathe it in every day. It comes off, but when you get too much, it can cause lung cancer.
Yeah.
And some places it can build up indoors, so it escapes from the ground and then gets trapped inside. So in
it's a denser.
Yeah, it's very dense. It's the heaviest gas known. I think it's like it's 9 times heavier than air.
The heaviest, I think, natural gas.
Right, natural. Yeah, the other one we're going to talk about is...
We'll get to mine.
It doesn't exist. But
it does exist, just for
it's
very,
created,
very tiny,
like
milliseconds.
And
it takes forever to make it.
That's all. But radon is 9 times heavier than air. And so... in 1984, there was what was called the Watrous incident, which is the highest reading ever that they found in radon in an area. And so a worker was set off the alarm. He was working at a nuclear power plant that was being built, so there wasn't actually any nuclear waste in there yet. And they were monitoring them just to, make sure you didn't have radiation. And he went like off the charts. And they're like, why? And they went to his house, and it was like as if he was smoking a few hundred cigarette packs a day. The levels were so high. In his house. And it was just because because certain places have higher levels of that than others, and it was just being trapped there. That's scary. That was why the EPA started monitoring levels in homes after that, because they realized it can be a problem.
So it could just show up anywhere. Right. So
there's a certain level that's allowable, and they do it in picocuries, which is a type of measurement. But like whatever the level is, that if you have above that is bad. If you have that level over 12 years, it's like smoking 10 packs of cigarettes a day or working in a uranium mine for 5 years.
Yikes.
Just by breathing in the radon. It's the second cause of lung cancer after cigarettes. So radon actually is thought to cause a lot of especially in non-smokers, the lung cancer. So it's bad, but what's really crazy is that in natural hot springs, there's radon emitting from those rocks. That's where it comes from. And so there's, a lot of people say there's health benefits to going to those hot springs and stuff like that. And then they did some research, and they say that it may have hormetic effect or hormesis, where toxins and environmental stressors have actual beneficial effects at very, very low density. Yeah. And so they're seeing that low levels may actually decrease the risk of developing lung cancer by 60%. So it causes cancer, but in really, really low levels, it might actually be beneficial.
Huh.
And they used to do radium salts to mix it with paint to make things glow in the dark until they realized that was a terrible idea, and they stopped doing that.
Wait,
this is not good. So I thought it was very interesting. So it's it's radioactive, but yet at the same time, we're learning now more and more. We research more of this stuff that it really depends on the level and how much of you're exposed to, that whether it goes from either nothing or terrible or great. Kind of crazy. Science. So that's the last of the natural noble gases. Grace is going to tell us about this other weird one.
Okay. I'm going to try my best to pronounce it. Oganesson. It's atomic number 118. So for a while, when a bunch of scientists were just trying to create new elements in a lab,
because they like to do that.
Actually,
like there's a whole bunch of them on the periodic table.
And it was easier. I read it's actually easier to create an even numbered. Because I think just because of their structure versus an odd numbered one.
Interesting.
But it is a synthetic element made in a particle accelerator.
They take little particles and go. Pow!
They're like, we think this is a noble gas. However, it's considered by other sources to be a radioactive solid. So my resources are a little conflicting, but in the periodic table, it is in the noble gases.
This is true.
So it was discovered in 2006 by scientists from a joint institute for nuclear research in Dubno, Russia, and the Lawrence Livermore National Laboratory in California. It's named after a chemist, Yuri Oganesson. Oganesson. Oh, gosh.
Had to have a confusing name, didn't he?
He had to be named after him.
Why didn't they just named it like the Californium, like they did for California?
and Berkelium.
And Berkelium.
And Einsteinium. They're just like, why are we trying all this hard stuff? What is the name of this? So, it doesn't last very long. It's made and then it falls apart. And
that's pretty much all of the man-made ones.
All the man-made ones. But I am going to read a little quote from the book that inspired
this podcast.
Our podcast.
Yes.
From Hugh Aldersey Williams. It's a little quote actually from Yuri Oganesson. Oganesson?
Oganesson.
Because his name is Yuri Oganesson.
So they didn't want to do his like straight name. He should change it a little bit.
You know, he was putting a flair to it. And so he leads the team that synthesized the element numbers 114 and 116 and he got to be named after the 118. It says odd number elements are harder to obtain for reasons to do with nuclear stability. So the author of this book asked about the distinction between finding and making elements. And Oganesson said, I'd put the question more rudely, why in general do we discover elements? And he said, the discoveries are important less as trophies and more for what they tell us about the wider world. So I know in a lab, it might just seem like they're wasting a lot of money, which they might be. Just kind of being like, I wonder if we accelerate this enough, if we could just make another element for just like 3 seconds before it completely falls apart. But if you really look at it, though, I mean, it's like they're really just trying to understand.
It tells us a lot about how things react and why they react, and will tell us more about the things that are naturally occurring in our environment because of that.
It's not a total waste of time, but did I say what year this was discovered? Did I say 2006?
No,
it was in 2006. So, I mean, our noble gases range from the 17. 17. Well, 17.
Yeah, I mean, they knew they didn't know no, but they isolated it in 17. Knew something was up in 1785.
From the 1700s all the way to 2006. I mean, they're still just they're not discovering new elements; they're creating new elements because all the elements in our world have been discovered. Just not all of them have been created. Right? So
possibly.
I'm really excited to see what we get from the Mars.
Oh, yeah, the one that just landed.
Yeah.
They didn't crash it this time.
I know. I actually
they were very excited.
I was monitoring it. And I was like, please don't crash.
Well, you know what I think is funny is that the news articles around that was not like, yeah, we got a probe on Mars, it was how excited the scientists got. But that was the story. But was like they were so excited. Like, look at these crazy people getting so excited. I'm like, they landed the thing on another planet. Of course they're excited.
Did you read the oatmeal?
No.
So do you know?
Yeah, of course I
we
do.
We
We ran the race. Hello.
The guy who
we bought the book. Okay.
He made a really good comic about it before it landed. They're like, Insight's landing this Monday. He's like, this is why it's so, like, if they land successfully, like the way he described, and he tells you all the mathematical points of like what degree it has to enter the atmosphere. Yeah. Too sharp of a degree and it'll burn up completely, or there's a very small window. Yes, and then there's like 6 minutes of time where they won't know whether or not it crashed.
It's a blind scan.
And then like there's this shield because it's coming in so fast that like it's going to be like thousands of degrees in temperature, and then that pops off, and then they have like reverse rockets to slow it down because it has to. If it doesn't come in at a certain speed, it'll just like get trapped. And you have to go past it. Yeah. And then if it's too fast of a speed, it won't be able to slow down fast enough. It'll just crash. And I think it's something like only 40% of the.
Of things actually land,
of things sent to Mars have actually landed successfully because this window is just like it's like
threading a needle.
Yeah.
Yeah.
And like, well, let's hope you don't land on in
rock.
The canyon, like because Mars has that canyon that's like the length of the United States, so like we also have to make sure that's not happening. And then like
it's a lot of math and physics that go into that.
Rockets that had to be go off at just the right time so they can slow down enough so it can land. Mm-hmm. Also, that they can send the mole in to dig a hole into the ground to see what the take core temperatures and to see maybe like if there was life on Mars, why it no longer exists. Right. And it's just like it's so cool.
Well, it's as much fun as I make fun of the elements that have been created in labs and how somewhat silly it seems to create something for a millisecond, but it really hammers down the point of research for research sake. Mm-hmm. So sometimes you don't have an end goal in mind for I need to do this to create this, but some of the greatest things that we've gotten have come from these other things of just knowing this about the world and about the planet and about the outside. Like it informs us so much that then we can use that information to go over here. And so I think a lot of people don't appreciate that, and they're like, oh, that's a waste of money to do that. Like, well, no, it's not actually.
Yeah, you got to look at the big picture.
Yeah, that's hard to do sometimes.
Well, yeah. We're all very focused on our own lives and wondering why some chemist is shooting a laser with
right.
Laser. But
but then you get LASIK.
Didn't.
Right.
I would still be wearing glasses.
And that would just be terrible.
Well, it wouldn't be actually terrible. No. I mean, I survived quite a while. I say to someone who's so wearing glasses, but it's nice. I like being able to see. I like that when I wake up in the night, my husband's like, "Look at the moon. I can see the moon. I can see it."
Thank you, science, and turkeys and lasers, and crazy scientists that think outside the box. Science and turkeys and lasers. On that note.
I think we're good.
Yeah.
I think we covered these.
I think we covered it all. Except for helium, it gets its own special thing.
Oh, it totally gets its own episode, which will be awesome. So, again,
subscribe.
Subscribe, email us if you are offended.
Or if you just like us.
Feel free to tell us about your journey into learning about science if you want to. Or if we got anything wrong.
Anything right.
Or anything right. Did we get anything right?
Anything good?
So that's
feel free to contact us.
Yeah. And
see you next time.
Yeah, thank you so much for listening, and we won't see you. I say that.
You said we're not going to see them. No, we won't even hear them. No. Well, we'll talk to you next time.
We'll talk at you sometime soon. Have a good day.
Toodles.
Bye.
Bye.
Cindy thought it'd be a good idea to do a test without me.
Hey, she's sitting right here. She could have talked.
Yeah, I was busy doing research.
Oh, I already did my research.
Okay, I'm smart and I do things in advance.